As you all know, Enterprise has been working on sustainability in multifamily housing since 2004. And this event with Sandy has been a really, it's been an interesting turning point for our program, because it's really the first time that we have had to go from thinking about climate mitigation to really starting to think about how climate adaptation affects multifamily buildings. And so the work that we're doing and that Lori is leading with our multifamily Sandy Learning Collaborative has been a real eye-opener for all of us who've been able to see some of the impacts that Sandy has had, and starting to think about how we prepare not only the buildings for future events like this, but also the way that the organizations are prepared to respond to these sorts of events, both in the immediate aftermath of crises, as well as in making sure that the work of preparation that really ought to be happening in advance of these events are being incorporated into the sort of core DNA of what our organizations do. So that's really all I had to say. Welcome to our office. Thank you very much for joining us, and I'm just going to turn it over to Lori here.
Thank you, Bill. Welcome, everyone. This topic of power generation, backup power, has been very important for our community of affordable multifamily housing providers, and backup generation came in handy for many of us who were trying to figure out how to power up pumps and other vital equipment during and immediately after Sandy. So we're really happy today that we can gather and hear from Brian and Scott about backup power strategies that work. Sorry, folks, we've got 50 people on the. So I just want to quote something from the National Electrical Manufacturers Association, NEMA, which is a network that really informs a lot of what we do in the electrical generation field. And basically what NEMA is telling us is that smart technologies are in place, power outages are avoided, and lives, homes, businesses are protected. Resilient and reliable power is critical for first responders, communication, healthcare, transportation, financial, water and wastewater treatment, emergency food and shelter, and other vital services. This is a really important session today because we're going to be learning from experts around the strategies that will work when there's an emergency event, and how do we recover in an expeditious manner. So with that, I would like to welcome our first presenter, Brian Cronin. Brian is president of CSA Engineering Services. He has extensive experience in generator control and protection design, switchgear application designs, and construction. Additionally, Brian has experience in development of specifications, testing, operating, and instruction manuals. He is a licensed professional engineer in New York and has been doing this for about 30 years. He's been both at the design level and in the field, and we're really excited to have him speak today. Brian, please.
Good morning, everybody. Happy to be here today to try to cover some of the basic topics associated with backup generation. I thought for a while about what I would call this presentation. Originally, I thought I was being brought in to do a topic on homebrew, and somehow it turned into backup generation. So I know it's very important to have backup generation for the breweries and things like that. But what the color scheme kind of hides on you is meeting a backup power needs, but what's hidden is and wants. I look at backup generation from code issue, legal issues, as the purpose of backup generation is to evacuate a building. That's it. Codes have been in existence for a while, mostly with that. There's certain populations, such as healthcare facilities and the like, that have other life safety needs. But generally speaking, when you look at building codes for residential applications, those backup generation is for just evacuating a building. It's not making power available when you have a power outage for 23 days because of a storm that has destroyed an electrical infrastructure. So what has come on is not only the needs for backup power, but also the wants, what people have decided to come up with. And I'm not sure if this will just page down, but it does. Okay, so what is backup power? A lot of people might carry a flashlight around in their pocket. A lot of phones these days, I haven't done the app yet, but you can make a flashlight out of your own phone, kill the battery in about, I don't know, 15 minutes. You can have a UPS system. That's a static device that is charging a battery and gives you a certain amount of supplemental power, but they're generally not designed to operate that long by themselves. We have conventional generators, which probably everybody would think of when they were thinking of a backup power supply. And then there are alternate sources of energy, which would include combined heat and power. Some people call that cogeneration, some people call it distributed generation. There's a bunch of different words that float around that kind of do mean the same thing. And then there are also solar and wind. Scott, next speaker, is going to go over some of the applications associated with solar. I'm just trying to do a generic application to generation and alternate sources of power. So there's a lot of stuff written on backup generation. A lot of it is useful, a lot of it is blah, 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 blah. You should do this, you should do that. A lot of mom and apple pie. You know, light should stay on. Okay, that's great, but and then there's a lot of read between the lines, and in some places there is certain contradictory information that you should do it this way, no, you should do it that way. So a lot of it has to do more with the application of where you are, what you're doing with it, things like that. But there are codes, National Fire Protection Association, National Electric Code, generally what you would use to have ideas for or directions for how to build things, how you do electrical systems. They have, National Fire Protection Association likes to write. They got documents that go on forever and ever. One of those documents is a standard for emergency standby power systems, which kind of tells you how to make, design, use generators, things like that. And then the life safety code, which would be more healthcare facility related, what you have to do to maintain life safety and things like that. IEEE, giant electrical organization, they also like to write too. And then there's different building codes. You have the International Building Code, which is generally a relatively standard document that's used by most states and municipalities, altered with their own local jurisdictions. Then the International Fire Code is another big standard with respect to backup generation. And again, firefighters want backup generation more than anybody, because their job is to safely evacuate people in a fire. They're also called, even non-fire issues, they're going to be called first responders, one of these things. Just so they can get people out of the building. They need the lights to stay on that long. They need elevators to operate. So if you think of evacuating a building, you get a good understanding of what backup generation has to be. Local body having jurisdiction is your local community building group, whatever they are. New York City has this thing called the Department of Buildings. They would be kind of like the department, the body having jurisdiction. But then they also have the fire department, and sometimes they might not agree on exactly the same way to do things. So you have to really have a good sense of who the local body having jurisdiction is in the area where you are. There are some communities that say, oh, you want to put a generator in? Have fun. Others aren't so nice. And then there's underwriter laboratories. They test to make sure equipment that the manufacturer is made safely. And then factory mutual is a big thing, because when it comes to developing standards, I always get back to everything has to be about money somehow. Factory mutual, the insurance company, wants everything. They don't want to pay out necessarily if they'd like to avoid any claims. And if they've come up with standards that are very good standards, that give you a good idea of how to go about building things from a casualty loss perspective. So there's a lot of information out there, and in your lifetime, you might be able to look at it. There's an IEEE book called Recommended Practice for Emergency and Standby Power Systems for Industrial and Commercial Application. If you open the book, like the first page asks 4 questions. One is standby power required, and is that legally required, or does the operation of the facility require it? Not legally, but is it truly needed to operate the facility? What type of system is most suitable? If I have something like wind power providing backup power to me, and there's no wind, I kind of don't have backup power. So would that be satisfactory? Is that suitable? If I have a natural gas generator, and because of the storm, the natural gas lines are taken out of service, I don't have natural gas, so I don't have backup power. In New York City requirement, for example, you have to be able to store fuel on site to be considered an emergency generator. And you can't store anything pretty much in New York City other than diesel. So there are biodiesel, a couple of alternate fuel sources that aren't the mainstream, I would just say. And then the other thing, can an existing, if you're thinking about putting it in now, can your existing system be retrofit? Is that a simple solution, a complex solution? Is it really a viable solution? And then what are the operating and maintenance requirements? Do you have staff available? Would you know what to do, how to start it, how to run it, how to maintain it, things like that. So I think when you take these 4 basic questions, it really tries to help you think about what you should be thinking about when you're looking at backup generation. So, is it legally required or optionally required? I hope everybody in this room knows that if they have a legal requirement, they're already fulfilling that legal requirement. But the way building codes are, as the building code changes, you typically don't have to upgrade to that building code unless you go and touch something. So if you built your building in with the 1968 code, and you have a building that wouldn't meet today's code, you don't have to go and change it every time the code comes out. So, but if you're going to go make some changes to it, you have to come and comply with the code in many cases. So, so you have the legally where they're legally required would be defined by codes, local ordinances, or even insurance plans sometimes. Well, they're optionally required. What's the function of the facility? If I'm a healthcare service provider and I have people on oxygen that need electricity, or they, to make that oxygen, or they have a certain life support system, that's a critical thing that's defined by a code. It is a facility function too, so there is certain overlap. If I have an elderly population, for example, that lives in a residential high-rise, I might not legally be required to have backup power for an elevator, but are you going to be able to make 83-year-old people walk down 37 flights of stairs? Do you have a legal obligation? Not necessarily, but as codes have come on and changed, now that does exist, and those are defined by code. But there are, a lot of older buildings just don't have something like that. So that's an instance where you may want to consider a retrofit of an existing facility, and can you do that reasonably? Does the facility have a desire to have backup power? Do residents have to have water, heat? Do they have to have refrigeration to keep their food fresh? Do they need to be able to charge their cell phones so they can talk and complain to people about how bad this outage is? Things like that. Is there a desire? And then certain insurance companies may offer discounts on insurance for, let's just say, for a security system, where you would have a backup generator. If you have an outage, backup generator could be a good thing to maintain the security of the building, and you might get an insurance discount. So there's a lot of different reasons why people would optionally choose, and the biggest one is because they want it. So what does the International Building Code require? It's just a list of many of the applicable residential housing where you would require backup generation. So any place you have an assembly, for example, an assembly place, again, we get back into we need to evacuate in the event of an emergency. That's a big thing. You have masses of people put together. That's really where it is critical to have something like that. If you have smoke control systems, exit signs, probably in every single building, you typically would have an exit sign, and it's got a backup with a couple of lights so you can get down the hall. The means of regressive illumination, same exact thing, a lot of times it's aligned with the exit signs. You have egress elevators. Again, do you have a population that can't walk down a flight of stairs? Do you have doors that are locked electrically? You know, how do you get out if you don't have an easy means of doing it? Any high-rise buildings, underground buildings, elevators. And so this is what I consider mom and apple pie codes. They tell you to do it. You have to have it. But they don't really tell you how to go about doing it. When you go to the fire code, they'll actually say the same exact thing, except for, you know, you have to read the fine print. Not that I'm expecting anybody to read this, but this will go into the details of the standby power in a high-rise building, where the fuel supply has to be, what the capacity has to be, how you connect to the different facilities. So it gets a little bit more into the weeds, but it's not a complete and total design document. And then there are other things associated with that. So, but this is what codes kind of talk about when they do it, when they go into it. And then the local body having jurisdiction, New York City, writes their own document of what should be included in emergency generation. You have fire pumps and booster pumps, elevators, alarm systems, communication systems, emergency lighting, ventilation systems, stair pressurization systems. Again, these are all, if you think about them, what do you need these things for? Fire pump is probably, if you have an issue with a fire and you have no power to operate that fire pump, that's probably a pretty good thing to have, isn't it? Elevators, again, you want to evacuate the building. Lighting so people can see. So things like that. Stair pressurization systems so people can breathe. New York City also has an interesting thing. A number of years ago, they came out with a document that says even if you're not legally required to have a generator, when you put it in, you have to put these things in. So they want you to connect emergency lighting, a fire alarm system, and at least one elevator that serves all the floors. And then you can go and put what you want to put in. You know, your refrigerator, your air conditioner, your whatever. So even though this is optionally required, you're not required to do it by law. If you go about doing things like this, you have to go and do it. So that's how the codes get involved. And then when you look at other either optional or really required systems, do you have a healthcare facility? You know, healthcare facilities have certain backup power requirements. Do you have an at-risk population that really needs it, whether it's a security, whether it's egress, whether it's additional health issues, whether they just like to complain a lot and need it because their neighbor has it, you know, the resident convenience. And again, you know, you think about it, the same recurring theme. What do you put on backup power? The typical would be lighting, elevators, fire alarm, fire pumps, sprinklers, sewer pumps, ejector pumps, central alarms, security systems, things like that. What we're starting to see now with people wanting backup generation is we need water. You know, it's a very big thing. Every tall building needs a pump to pump water up so that you can at least run water. You might have water in the street, but not enough street pressure to fill your tanks. So that's one thing. Heating is another big thing. You don't want, not only do you want it for resident comfort, but you don't want pipes freezing and causing additional problems. Lately, we're seeing a lot more people wanting air conditioning too, because when you're in the middle of a summer in the sweltering heat in a building where you might not even be able to open some windows, it becomes a bigger issue. So more and more comforts are required. What we do in some areas, in some buildings, we've made certain rooms, for example, like a community room, we would provide some backup power to that. So not necessarily individual apartment buildings, resident buildings, but an area that would be the part open to the general public. So what are the components of a backup power system? You have to have a source. How do you make electricity? You have to be able to transfer that normal source to that backup source. And you have different types of load. So just depicted here, I have a portable generator, a transfer switch, and a panel board. So if you look at that as the source, the means of transfer, and the load, that's what you have. So, my start to try and explain the generator system is to start explaining what a car is. And I think most people would know what a car is in this room and how to use a car and what's required with a car. So I figured I would go with that. So if you're going to go and buy a car, you look at, you have the capital investment and you look at the different features. What kind of feature do you want in a car? If you have 6 children, are you going to get that Mazda Miata that's really cool looking? That's probably not the right size car for you if you have to squeeze 6 children in the trunk, because the trunk doesn't hold a lot. So you have the size. Do you need air conditioning in the car? Do you want power brakes? Do you want airbags? You don't seem to have the choice at some things, but there's certain features and options you can add on. And what they do is they add to the cost of it. When you look at the operation of the car, you can choose the fuel. Anybody remembers the Volkswagen Rabbit commercial with the diesel? You had to follow that truck. But now there are a couple other options other than diesel and gasoline. How do you go and start the car? In some cars, we live in the colder neighborhood. We don't like to go outside in the middle of the winter, so we start the car and let the heat warm up the car for 25 minutes and get that gas mileage down really low, but the car's warm. Do we have to start it with a key? Do we have someone go start it for us just in case we have enemies and we don't want the car to blow up on us? So there are different starting requirements they have. You have license and registration associated with the car. If you're running around without a license, you could, but you might get into trouble. And then you have auxiliary operations associated with the car. You have your charger in the car so you can operate your computer while you're driving out on the highway when traffic's really busy. Nobody does that. And then there are maintenance, repair, and storage issues associated with the car. You have the size of the car, the different parts of the car are very, very, very similar to a conventional generator. So what are the power sources that we could consider for backup power? So you have generators, batteries, or alternate energy sources. So when I say alternate energy sources, that could be almost anything, even things that haven't been invented yet. So I'm covering all my bases. But typical fuels would be diesel, natural gas, propane. There are dual fuel and bi-fuel machines. Dual fuel means you can operate on either one or the other fuel. Bi-fuel means you can operate both at the same time. You have solar and wind power available. It would be considered a fuel in this conversation. You have the ability to have a stationary generator, one that sits there forever, or a portable generation. I have a few buildings. I'd like to cover those buildings by moving generators from building to building because I might not have an outage at every single building at the same exact time. And then, everybody remembers the 3 most important things about real estate are location, location, and location. The 3 most important things about siting a generator or some backup source are location, location, location. It really does impact a lot. It impacts how people feel about the generator. Out of sight, out of mind is a great thing. One good thing is if you have a generator and your neighbor doesn't have a generator, they don't want to hear it, they don't want to see it, they don't want to. So you have certain aspects of the environment, if you will, that you have to pay particular attention to. Certain generators are as loud as anything, and noise will travel either directly from audible noise, but also vibration noise, things like that. So it can be an issue. Can you exhaust it? Are you close enough to exhaust it? One of the things about an emergency generator, the code allows you to exhaust it at street level if you really wanted to. Not a great thing to do, but certainly a certain aspect of it is not as critical as something that would be a permanent, normally full-time running device. You have security associated with it, easements, permit issues, operating personnel. Do you have the right operating personnel? Or is it just one of those things, I got it, I put it in, I don't ever want to look at it again, but it better come on when the lights go out. So there are things that we look at when we talk about just the source of generation. Does this look just like the car I showed you a little while ago? It's got an engine in it, it's got a little alternator in it, and no front bucket seats, but we could put them in there if we wanted to. So, but in the what are components of the generator? You have the engine, the governor, the muffler, the radiator. So you have to generate it, you have to run the engine, you have to cool the engine, you have to exhaust the engine, you have to control the engine. You have the fuel pump to feed the fuel to the engine. You have to start it. How are you starting it? Typically, if you're starting with batteries, you can start with compressed air and other things. So there's a bunch of different things. But if you have batteries, then your battery charger. And then now that the mechanical side of it now spins a generator. So that generator needs to also be controlled. You need to regulate the voltage out of the generator, and you need to protect the electric system that it's connected to. So that's the main circuit breaker. Some of the things not shown in this open generator are what are you doing for fuel storage? Is there an enclosure? Is it going to be inside the building, outside the building, somewhere? How is it protected? Is it secure from people? Things like that. So the installation requirements are going to be a big aspect of installing a generator. You know, if you have this room that's great and unused and things like that, but you can't bring the generator to it because of whatever reason, probably not an ideal location to install the generator. If you want to eat up a parking space in a housing area now, a lot of people might start throwing rocks at you because you're taking their parking space from them. So those are the issues that you have to deal with, just basic issues with installation. And then in transfer equipment, you know, when you're considering transfer equipment, do you do auto or manual transfer? You know, again, is it one of those systems you want to have that nobody has to think about? It just starts the generator automatically and transfers over the load automatically? Or do you have a manual transfer switch that somebody would have to go and say, yep, turn this one on, turn this one off? So when you are looking at transfer switches, you have the size of the transfer switch for the load requirements. You know, how big does that transfer switch have to be to meet the electrical load duty, fault duties, things like that. When you're controlling and monitoring it, or there are certain control and monitoring aspects of it, again, auto or manual. Do I have open or closed transition? What open transition is, if there's an outage, that obviously there's an outage and then the generator starts and you transfer over in a certain period of time. 10 seconds is a typical starting time. But when you're coming back and the utility is there and the generator is running, you can have an open transition, which means you shut the generator off and then go back to the utility. Or a closed transition is there's no outage. The generator and the utility come together and you don't see any type of blink in the lights when it's returning. How am I going to start the generator? What's the reason for starting it? You know, how do I want to do it right away? Do I want to give it a couple of minutes? Do I want to exercise the generator periodically? Transfer switches could do that for me. Do I want to have status of the transfer switch or switches and metering? And what kind of load am I running? Is that helpful information to me? Where am I going to locate it? Is it going to be close to the load, close to the generator? Is it easy to install it where my existing electrical infrastructure is? Do I want multiple transfer switches? So if I put a generator in and the load's bigger than I thought, or I want to have the ability to put a smaller generator in and share different loads, I could have multiple transfer switches and then selectively choose what loads I wanted to pick up. So I can keep my capital investment a little lower. Other ways to do it are interlocks. So you could have a switching scheme that would prevent you from closing one device before you opened another device. And then other ways that it's done is, particularly if there was no generator in mine there, and you saw a lot of this in Sandy, that they cut away the electric supply and put cables in where the electrical supply cables were. That's just what I'm calling cable swap. So there are different types of electrical loads that have to be considered when you're sizing a generator. But the different types of loads would be resistive loads, like a light bulb, an incandescent light bulb. It's just a constant load source that it's a nice thing for generators, they're happy with it. Then you have reactive loads.